Hi there, this is Simple Harmonic Motion, Lesson 2, Velocity. Velocity equations for SHM. So the velocity v of an object oscillating with simple harmonic motion varies with displacement according to these equations. So the first one, velocity is equal to plus or minus. The plus or minus just indicates which, it could be either moving to the right or to the left, or up or down. So plus or minus omega. And then it's the square root of amplitude squared minus displacement squared. And obviously the omega is 2 pi f and 2 pi over t as well. Omega is 2 pi f and omega is 2 pi over t. We should know this by now. So if you want to write these down. Then we need the equation for max velocity. So maximum velocity, if you remember from last lesson, occurs at the equilibrium position. So the displacement x would equal 0 at that point in time. So what we end up with is max velocity is omega. The displacement x is 0. So we're left with the square root of a squared. Square root of a squared. It's just the amplitude. So there's the four equations. So Vmax is omega a. We've got the top one. And then these two from circular motion. So make sure they're written down. And then we'll just do some example questions. So let's move on. So a body moves with simple harmonic motion of amplitude 0.9 meters. What is the speed of the body when the displacement is 0.7 meters? So we're going to use the velocity equation. V equals omega square root a squared minus x squared. And in this instance, we've got the time period, so omega is 2 pi over t. So that gives us velocity is equal to omega, which we're going to say 2 pi over t, square root a squared minus x squared. So the velocity is 2 pi divided by the time period of 8.9 seconds, multiplied by the square root of 0.9 squared minus 0.7 squared. And that gives us a velocity of 0.4 meters per second. Pretty straightforward. Hopefully that went okay. Let's have a look at the next one. Remember to pause at any point in time or rewind if you need to. So the next one. So we've got a body oscillating with simple harmonic motion as a period of 4.8 milliseconds and an amplitude of 32 micrometers. Calculate, number one, its maximum speed, and B, its speed when its displacement is 15 micrometers. So let's do Vmax first. So Vmax is equal to omega A. And we've got the period, 4.8 milliseconds. So what we can do is Vmax is equal to omega, so 2 pi over t. So 2 pi divided by 4.8 milliseconds. 4.8 times 10 to the minus 3. Multiplied by the amplitude of 32 micrometers. So 32 times 10 to the minus 6 meters. So that gives Vmax of 0.042 meters per second. Let's do part B. So V is equal to omega 2 pi over t square root a squared minus x squared. Then we just need to put our numbers in. So V is equal to 2 pi divided by the time period, which is 4.8 milliseconds, 4.8 times 10 to the minus 3, multiplied by the square root of 32 times 10 to the minus 6 squared, minus 15 times 10 to the minus 6 squared. So that will give a velocity of 0.037 meters per second. Hopefully that one went okay. Let's have a look at the next one. So you want to pause and have a go. An object of mass 0.2 kilograms performs simple harmonic motion. It oscillates with an amplitude of 60 millimeters and a frequency of 0.8 hertz. What is the maximum value of the kinetic energy? Well, to get maximum kinetic energy, we're going to need the maximum velocity or maximum speed of the object in question. So we need to do Vmax is omega A. And we've got frequency, so we're going to do 2 pi f. So we've got 2 pi f, so 2 pi times the frequency 0.8 multiplied by the amplitude, 60 millimeters, so 60 times 10 to the minus 3. So that gives a Vmax equal to 0.3016 meters per second. The reason I've done this many significant figures is because it's an intermediate calculation and we've yet to find the kinetic energy. So the kinetic energy is equal to a half mv squared, so we need to do a half times the mass, 0.2, multiplied by the speed squared, so 0.3016 squared. And that gives a kinetic energy of 9.1 times 10 to the minus 3 joules, or 9.1 millijoules. Hopefully you got that one. Let's try a different one. So if you want to pause and have a go at this one. So a particle of mass 5.5 times 10 to the minus 3 kilos, moving with simple harmonic motion of amplitude 0.15 meters, takes 46 seconds to make 50 oscillations. Again, what is the maximum kinetic energy of the particle? So again, we're going to maximum kinetic energy. So we need maximum speed. And this time we've got 46 seconds to make 50 oscillations. So we can get the time period per oscillation. So that'll be 46 seconds divided by the amount of oscillations. That'll give us the time for each one. So each oscillation takes 0.92 seconds. So that's the time period. So we can get max velocity now, or max speed. Vmax is omega A. Omega, we're going to use 2 pi over 2. So 2 pi divided by the time period, 0.92, multiplied by the amplitude, 0.15 meters. So that gives a Vmax of 1.0244 meters per second. Again, I've used 5 significant figures this time, because it's an intermediate calculation. Really, you should use the entire number in the calculation, square that value when finding the kinetic energy. Kinetic energy is half mv squared. So we need to do a half times the mass. The mass is above. 5.5 times 10 to the minus 3. Multiplied by the speed squared, which is the 1.0244 squared. So that gives the kinetic energy this time of 2.9 times 10 to the minus 3. Or 2.9 millijoules of energy. Hopefully that's okay. Let's try one more. So let's pause and have a go. A particle of mass 0.15 kilograms moves with simple harmonic motion of amplitude 2 times 10 to the minus 2 meters. If the total energy of the particle is 5 times 10 to the minus 5 joules, what is the time period of the motion? Now the first thing that we need to appreciate is this is the total energy, and the energy as the mass is undergoing simple harmonic motion will consistently be changing between, a mix of potential energy and kinetic energy. But there is a point when it's passing through the equilibrium position where that energy will all be kinetic. So we can use this value as the kinetic energy. So kinetic energy is equal to 5 times 10 to the minus 5 joules. So from that we can find the maximum velocity or the maximum speed. So kinetic energy is a half mv squared. So if we times by 2 divided by m and square root, we get Vmax if we use the maximum kinetic energy. So V is equal to 2 times the energy divided by the mass and then square root. So we've got 2 times the energy, so 2 times 5 times 10 to the minus 5 divided by the mass, which is 0.15, and then we just need to square root that value. So that gives us a maximum speed of 0.0258 meters per second. Just make sure that number's correct or written down if you got this wrong. I'm going to clear the screen and move on. So we know that the Vmax equation is omega A. And we need the time period. So I'm going to do Vmax is equal to 2 pi over T times A. So it's 2 pi times the amplitude divided by the time period. So the time period, nearly done here, is equal to 2 pi A divided by Vmax. So let's put some numbers in. So 2 pi times the amplitude, 2 times 10 to the minus 2 meters, divided by the max velocity, which is the 0.0258. You should use the full number. Just put 19 in there. Should be enough. There is guidance for all exam boards that if an intermediate calculation should be done to a minimum of 5 significant figures. So there's 5 there. The best thing, of course, is to just leave the number in the calculator, use the full number. So if we do 2 pi times 2 times 10 to the minus 2 divided by Vmax, we should get a time period. It's 2 significant figures of 4.9 seconds. And remember, I've chosen 2 significant figures for the final answer because all the pieces of information that are given to me are 2 significant figures. Hopefully that went okay and you got that right. Thanks for watching. I'll speak to you soon.